So once I solved for y and plugged it in for the max, I'm going to find the vertex. That was the idea, right? You solve for one of the variables on the given, plug it into the variable for the max. You should get a quadratic. You can find the vertex. This you got to clean up, and that's not 9x plus 64 because you got to do this double. So that would be x squared plus, that would be 9x squared. Here you distribute your 3x, you distribute your 8. And then you get negative 24x, positive 64. And those two go together to give you negative 48x. So, x squared plus, oh wait, that's 10x squared. Can you read that too? Oh well, that's a 2. And then minus 48x. What? What happened? Yeah, these two dudes right here. Yeah, these two dudes went together and gave you 10. Okay, good. I'm glad you asked. We're getting better at this communication thing. Okay, so now you got this. What do? This is what sucks about this problem is you started off with a game plan, and by the time you did all this work, you're like, I forgot my name. You know? It's like, what am I doing here? You got to find the vertex. That's right. So, negative b over 2a. So negative b, that's a negative 48, right? And then that would be 2 times 10. So 48 over 10. 20 over 20. Is my math, I'll really rush through that. Does that seem okay? So 48 over 20 is 24 over 10, which is 12 over 5. That's how I reduce my fractions by 2s every time. It takes me a while, but it seems like it works. And I will say that going real quick through these problems, some people might say, slow down. But for me, I don't get, if I just I try to do it real quick, and then that way I don't get lost in what I'm trying to do. You know, just a second ago, I was like, well, what do you do after you do all this work? That's what I'm trying to get at. I don't know if that makes any sense, right? What is that, by the way? Is that the x value or the y value? Yeah, it's the x value. How come? Well, this right here, if you had started, now a second ago, if you had started and solved for x, okay, let's say you solved for x, and then plug the x in, you'd have nothing but y's. And you'd go all the way down through here and you'd get a different number because that's the y value. So whatever you solve for, and then you're going to, whatever these letters are right there, that is that value. Okay? So if these are x's, that's the x value. And how do you find the y value after that? You plug it back in. Where would you plug it into? This guy? You're actually just looking for this y value, not the actual vertex. You're looking for, you're trying to look for just basically the highest point, the x coordinate of the vertex. That's weird. This is why I don't like using x and y's all over and over again. But you just do this once, and then you go back to the original and plug it in up there. Okay? Remember how on that fence problem, we went back after we found that number, we went back to our picture? Yeah, that's the same idea as we're going back to the picture up here. Does that make sense? I mean, if you're doing it down here, you're not fooling with the ranch anymore. You're not fooling with that rectangle. You'd have to go back up here to make sure you got the right fence numbers and stuff. Okay? So you always go back up here to the given. So you take your answer from there to the given. And now, yep, because that was an x value. So y equals negative 3 times 12 fifths plus 8. That'd be negative 36 fifths plus 40 fifths. Is that 4 fifths? You can use your calculator to do that if you had to. So on this question, you are stuck doing the algebra on it. Okay. If it's a rectangle, you're trying to maximize a rectangle. Remember, it's a square, so you divide by 4. You can do it like that. But if it says algebraically, show your work, they want you to find a vertex to get full credit.